Okay, good morning class. So today we're looking at calculus. We're looking at determining the equation of the cubic function. Determining the equation of the cubic function. And this is calculus. Examples for exercise. For exercise 6, which is on page 6 is on page 174. 12. Page 174. Okay. 13. Are you sure this time? Yes, 13. It is 12. Alright, so this example, I give example 1 on page 171. Okay. So we are told you may need to determine the equation of the cubic graph with or without using a sketch. If the x-intercepts are given, use the formula y is equal to a into x minus x1 into x minus x2 into x minus x3. Where do you see the resemblance of this formula? When you're working out the equation of the parabola. Not so, given the x-intercepts. Then we only have this part here without that given. Okay? However, because it has 3 intercepts, x-intercepts, and we follow this format of the formula. People, we're looking at example 1. Example 1 is on page 171. The question says, f of x is equal to ax cubed plus bx squared plus cx plus d. People, this is the standard form of the cubic function. It passes through the points negative 3 and 0, negative 1 and 0, 0 and negative 6, and 4 and 0. Determine the values of A, B, and C. So what we know about these people, let me cut the coordinate. What we know about these coordinates, if I draw this, okay, so we got minus 3 and 0 is there, so it must be an x-intercept, negative 1 and 0, another x-intercept, 0 and minus 6, of course, the y-intercept, and 4 and 0 is approximately there. Okay, so the graph could go up like that, down, and through like that. Not so, there's no way the graph could come like this and cut the negative 6 on the y. So this is what you should be seeing. So already I know my A value is going to be negative. Okay, this is just like an approximation of the graph, not exact. Alright, so where do we start? We know we are given the x-intercept. So we follow the formula. Y is equal to a into x minus x1, x minus x2, x minus x3. Where x1, 2 and 3 are x-intercepts. Not so. So what's my formula now going to read? Y is equal to a into x minus minus 3 becomes plus 3 into x minus minus 1 becomes plus 1, and then x minus minus 5, so x minus 4. So what cell needs to be solved here, people? The value for a. So to calculate the value of a, I'm going to substitute a point that we haven't used on the graph at this point as yet, which is 0 and minus 6. You guys understand? So you substitute. So you substitute 0 and minus 6. That's an x and a y. So negative 6 is equal to a into 0 plus 3, 0 plus 1, 0 minus 4. So what's 0 plus 3? 3, that is 1, that's minus 4. What's 3 times negative 4? Negative 12 plus 1 is negative 12a. Did I earlier say that A must be negative? Did I say that? Okay. The graph is first going up and down. A must be positive. Okay, so A is equal to? Oh. Okay, so what we do now? Yeah, we have solved the value for A. But do we solve C, B and D? No. So what we do is substitute the half into that formula. And then what we do thereafter, we get rid of the formula by simplifying the formula, multiplying it. So we got the formula now, y is equal to a half into x plus 3, x plus 1, x minus. So it gives to a half into x plus 3 into, multiply the story out, I'm going to get x squared, minus 4x plus x is minus 3x, minus 4. Okay? Go further and multiply this one. Now give me a half into, now x times x squared is x cubed. X times negative 3x, negative 3x squared, minus 4x. Multiply here, it will be plus 3x squared, minus 9x, minus 12. Which now gives me a half into x cubed, like terms, that cancels. That's going to give you negative 13x minus 12. Get rid of the bracket. It's a half x cubed minus 13 over 2x minus 6. What was the question? The question was determine the value of A, B, C and D. Now B is the coefficient of x squared. There's no x squared there, so B is going to be 0. C has to be the coefficient of x, which is negative 13 over 2, and then D is negative 6. Is that correct? So here we've underlined the A, so therefore B is equal to 0, C is equal to negative 13 over 2, and of course D is negative 6. Okay? Is there any confusion there? The next one, this is example 2. Example 2 is that right? Sorry? Same page. Okay. In example 2 we have told, consider the function f of x equal to ax cubed plus bx squared plus c plus d. Again, that's a standard form of a cubic function. We are told that f of 1 is equal to f of 4. Okay, I'll just do this myself. F of 1 is equal to f of 4 is equal to 0. When, if we substitute the x value in, do we get to 0? We would say solution. Not so. Or x-intercept. Not so. So in other words, the graph is going to cut your x-intercepts at 1 and at 4. You all agree with that? Okay? So these are x-intercepts. Then f of 3 is equal to 8. What does that mean? That is a point on the graph. If x is 3, y is 8. Yeah, if x is 1, y is 0. If x is 4, y is 0. That's basically what it means. So from here I could have drawn the coordinates. 1 and 0, 4 and 0. You see that? That is exactly what I have there. That's going to be 3 and 8. So if this is 4, 1, 2, 3, is approximately there, 3 and 8. Okay. Then we are told that f prime of 1 is 0. When do we say f prime of x equal to 0? When we work it out? Yes, it's your derivative, but when we say the derivative equal to 0? When we work it out? Stationary points. Oh, zero. Alright. When we work it out, stationary points. So what does that mean? That means that the graph is starting at 1 and at 3. So here the graph is starting at 1 and it's starting at 3. Now suddenly when you go with it, the graph is starting at 1. So if 1 is a turning point and it's an x-intercept, then that means to say it's a 2 in 1 happening here, not so. So the graph is going to bounce off there. But now you see there's an next turning point. So could the graph come down here? No. So the graph is actually going the other way around. Can you see that, people? The graph is actually coming from the side, bouncing off there, and cutting forward. The first question is to draw a sketch of the graph of f and indicate the intercepts and the turning point of points. There we go. You guys understand how to do it again? Okay, start again. Alright, so it says consider the function f of x equal to ax cubed plus bx squared plus cx plus d. We are told that draw the sketch of the graph of f and indicate the x-axis and the turning points. So as you can see here, f of 1 is equal to f of 4, which is equal to 0. So from here we can derive the point. If x is 1, y is 0. Yeah? If x is 4, y is 0. So as you can see, that if y is 0, then that's on your x-axis. Not so. Let's draw. On the x-axis we got 1 and 4. Okay. If we say f of 3 is equal to 8, so the graph is going through 3 and 8. At that point we didn't know it was a turning point yet, but we indicate that. So if x is 3, y is 8. To that point there. Then f prime of 1 is equal to f prime of 3, which is equal to 0. So we have a question we ask ourselves, when do we get the first derivative of your gradient equal to 0? At the turning point. So your turning point is at x is equal to 1 and x is equal to 3. Remember, I can't say this is 1 and 0 because that's not a coordinate. Okay? This tells us at which x value does the turning point occur. So the turning point occurs at 1, and normally as is right there, drawing a dotted line there, at the turning point, and at 3. But because the turning point is at 3, the graph has to do that. Okay? If you had gone the other way around, there is no way that we can draw a graph connecting those turning points without cutting the axis again. Can you see that, people? So, because of that graph thing, we will then connect the dots as follows. And there we go. That's going to 4, of course. Okay? Any confusion? Then in the B part of the question, or the second question 2, determine the values of A, B, C, and D. But we are going to get that from the standard form of the cubic function. Can you see that? The standard form of the cubic function follows the formula. Follows the formula. F of x is equal to ax cubed plus bx squared plus cx plus d. Okay. So what we notice here, we have that being 1, there's 1 and 0, and this is 4. So what, because we have our x-intercepts we write down the following. F of x is equal to a into x minus x1, x minus x2, x minus x3. You all agree with that? No? However, how many factors do we see here for x? We have 3 factors. How many factors do you see? 2. I say, hang on. This is actually a 2-in-1 story here. Not so. So if I take that graph and I move it down, can you see you've got 3 there? Then we got 3, 3, 3, 3, 3, 3 until it gets there. Then we get 1, 2 factors. But this factors here is actually a 2-in-1 factor. So you see that, people? This is a squared factor there. They're the same. It's a repeated factor. Okay? So what we're going to do is, when we write this out, we then say it's a into x minus 1, x minus 1. As you can see, it's a 2-in-1. Or you could have said x minus 1 squared. Yes? Sorry? 2-in-1. Okay, you see here? Let's take this down. How many factors do you see? Huh? No, it's 3. Yeah? The solutions, you have 3 solutions. Oh, you didn't know that, what I'm talking about. Okay. When I talk about factors or solutions, it cuts your x-axis. How many solutions are there? 3. 1, 2, 3. So you move that down. Oops, you move this down. 3, 3, 3 till you get there. Now your solution you get 1, 2. But this 2 solutions here became, the second solution, sorry, became of 2, where 2 became 1. When we now work this out, we'll see that that is actually a point or a 2-in-1 solution. So it basically cuts the x-axis twice at 3. So it's turning at that point. You understand? So whenever the graph bounces off your x-axis as it did there, know that is going to be a 2-in-1 solution. Okay? And we will have it as x minus 1 squared, or x minus 1 times x minus 1. Okay, and then the other factor is x minus, what's the x value here? 4. Whatever. So what still needs to be solved here? Of course, a. So what do we need in order to solve for a? We need another point on this graph. Do we have another such point on this graph? Yes, which is 3 and 8. So you're going to now substitute 3 and 8. Remembering this is the x and a 1. So what formula going to read now? A is equal to a into x minus 1 squared into x minus 4. What was the x minus 1 times? So what's my x values? 3. There's 3 minus 1 squared into 3 minus 1. Why? Because I'm trying to solve for a here. So what's 3 minus 1? 2 squared is 4. Now 4 times negative 1 is negative 4a is equal to. So what do you notice about the graph? The graph is first going down then up. So what should your a value be? Negative, and there it's confirmed that a is equal to negative 2. A is negative 2. But I ever answered the question? No. At this point we only have a. So let's calculate B, C, and D. And how do we do that? By subbing it back. So f of x is equal to negative 2 into x minus 1 squared into x minus 4. And then from there just multiply it out. Which is going to be negative 2 into x minus 4 into x squared minus 2x plus 1. It's negative 2 into x cubed minus 2x squared minus 4x squared is minus 6x squared. That's going to give you x plus 8x is 9x. Minus. It's going to be negative 2x cubed plus 12x squared minus 18x plus. Remember, the a value is already sorted. Therefore, b has to be 12. Your c has to be negative 18. And your d is 8. Just check if that's correct. Huh? Okay. Something like this is worth 5 marks. We go back to the graph, yes?
So with that, x minus 1, like if you have to do any other number, you like use 2 rules of the x minus 2 square root.
Yeah.
Okay.
So she's asking us here. The graph looks like this. So that is a 2 here. There's a 6. Then what should the formula now read? Y is equal to a into x minus 2 squared into. You guys understand? Any other questions? Simple, no? Right, so let's do example 3. Example 3 is on page. Sorry? 172 is the next page. Okay, so we are told that f is a cubic function. Consider the sketch of the derivative of f given that f prime x is equal to x squared plus bx plus c. Well, what is given to us? The derivative function. Okay, however, the function itself is a cubic function. So that takes us back a couple of lessons ago when we spoke about sketching of graphs. If the functional graph was a cubic function in that format, this means to say that a is greater than 0. If a is greater than 0, then the first derivative would be a smiling parabola, where minimum quadratic function, as this is here. So in our mind's eye, we already know that the graph is going to look like this. It's first going to go up, then down. Okay? Then we know that your second derivative will be an increasing linear function. So if this was your function, then the first derivative would look like that. You will agree with that? Yeah? And if a is negative, if a is less than 0, the graph does that. First goes down, then up. Would be a frowning parabola or maximum quadratic with decreasing and a decreasing linear function. In that order, always. Okay? We also know that the turning points are your x-intercepts of your parabola. Not so? And we know that the point of inflection is the x-intercept of that linear function. Okay? Alternatively, when a is less than 0, which means it's negative, the turning points, your x values of the turning points, no, not the turning points, the x values of the turning points are your x values of the x-intercept. And your point of inflection is your x value of the linear function. your x-intercept of the learning function. Okay. Now with that in mind, question says write down the x-coordinates of the stationary points of Earth. That is like plays in snake into what we have written there. Not so. So write down the x-coordinates of the state. What are stationary points? Standing points. So what are the x values of the standing points? It's going to be x is equal to 2 or x equal to what so? Which is which? We're looking at which comes first. What would that be? Would that be 4 or 2? You all agree it's this graph, no? Why? Because of the parabola graph being drawn. Why would that be 2? Because 2 is smaller than 4. So coming from left to right on your x-axis, coming from left to right, what's going to come first? 2. So, and x is equal to 2, the graph will have a local, what's this, maximum or minimum? Local maximum. That's on top. Why is it called local? Because that goes further up, not so. This comes further down. This is going to be called maximum and minimum. So you've got a local maximum at this point. Can you see that, people? And therefore, at x is equal to 4, so here 4, the graph will have a local minimum. Okay. If they ask you to explain why is that the case, you can say since for the function f of x, since for the function f prime x is equal to ax squared plus bx plus c, or f of x is equal to ax cubed plus bx plus c. X squared plus 6 plus c. But we can refer to this because that graph is given. So since f prime x has an a value greater than 0. How do we know it's greater than 0? You can see from the graph. Okay? Therefore, maximum will precede the minimum value. Or minimum turning point value. Yeah, you guys understand? Alright. See how much we got left for this question. According to the textbook, what they have that's actually question 2's, what's the name that I did one time? Classify each of the stationary points and justify your answer. I just did that as well. I've answered both here in this question. So for question 1, that is what they're looking for. The next is question 2. And then they said that in their explanation, remember they use the more theoretical approach. They are saying that if f double prime of 2 is less than 0. So the f double prime of 2, how do they know that? So the graph is concave down at x equal to 2, and the stationary points has to be a local minimum. So what they did was, they looked at this here. Okay? So the graph is decreasing here. So we must draw this graph. Remember, if I do something like that, so the graph must first go up, then down. Not so. So as you can see here, the graph is concave down. Therefore, this is a maximum value. Okay, that's approach right there. And because f is equal, if double prime of x is more than 0, so it's concave up, which is making it a local minimum. Okay, so either way, you'll get the full mark there. Okay, let's look at question 3. Question 3 says, determine the point of inflection So we know that the point of inflection always happens midway between the two turning points. Not so. So if this is 2 and this is 4, then the point of inflection will happen at x is equal to 4 plus 2 or 2 plus 4 over 2, which is 3. Did we have to do that calculation? No. So we say the point of inflection is at x equal to 3. And then we can also say that the graph is concave down, as you can see, for x's less than 3, and the graph is concave up for x's more than 3. As you can see here, that's the part that is concave. In question 4, they ask you to draw a sketch of the graph of f. People, that is really simple. I've done it already. Just redo it. So you got your 2 here, and you got your 4. Remember that the graph is going to look like that. Not so. Why? Because a is greater than 0. So what I do is I draw a dotted line going through 2, and a dotted line going through 4. And that is my guide for the turning point. So when I draw the graph, I just draw it like this. And there we go. And that is your f of x, and of course this is your f prime of x. I'll ask you to draw the second derivative graph. Then I just go through the turning point here, or that point where the concavity stops, and that is going to be your second derivative. Okay, and you know this is going to be 3. This was not asked, I'm just giving you as an enrichment purpose. Do you guys understand? For homework, I would like you guys to do exercise 13. There are 10 sums, you do the first 5. We'll make it the first 6. Okay, I'm going to go through this as well in video format so that I can have this for in the future. People enjoy the rest of the day and the weekend in morning class. Okay, good morning class. So today we're going to be looking at the last few examples dealing with determining the equation of cubic functions. So at this point we have concluded exercise example 1 to 3. Let's see what example 4 have been told for us. Here's example 4. This on the page. Okay. So here we are told that f of x equal to x cubed plus x squared plus 2x plus half has an x-intercept at 2 and 0 and a point of inflection at 0 and minus 8. Determine P, Q and R showing all these 3 calculations. So we have an x-intercept at 2 and 0 and a point of inflection. Okay, so how do you work out the point of inflection normally? How do you work out point of inflection? Second derivative is equal to 0. Once I do that, I'm actually calculating the x value of the point of inflection. Not so. So let's work out the second derivative here. So the first derivative, so they give you 3x squared plus 2px plus q. Remember, that's now a constant, it falls away. Second derivative, if double dash of x is equal to 6x plus 2q. Okay? But we are told that the point of inflection occurs at this point here. Okay, now say for argument's sake, this is the graph. This point of inflection here occurs at 0 and minus 8. So we see that at that point, f double dash of x is equal to 0. Not so? As I said, if you set this first derivative or your second derivative equal to 0, I get the x value at which the point of inflection occurs. And what is the x value at which this occurs? 0. So f double dash of 0 is actually 0. Okay. With that information, so now f double dash of 0 is equal to 0. So that would simply give us 6 times 0 plus 2p is equal to 0. That drops. Divide by 2 both sides, so p is equal to 0. There's back to p value, so this basically falls away. Okay. Then 0 and 8. So if the graph is going through 0 and 8, that means to say if I put x in, I get the y out. Not so? If I put x in, I've got the y out. So what I'm going to do is that you substitute 0 and negative 8 into f of x. Okay, so if we do the substitution, that's the x and the y again. So we've got negative 8 is equal to 0 cubed. Okay, just move it over. 0 cubed plus, remember p is gone now. So it's q times 0 plus r. So what's my r value? Negative 8. So the r is also sorted now. Okay? I would almost say that the turning point and your point of inflection seem to be at the same point here. Okay, because with the amount of information given here, I would need to use this point another time. Okay? Because what we have thus far is f of x is equal to x cubed. Oh, there's only one. Okay, qx minus 8. The other one is gone. So how many items are there still? There's one more unknown, not so. So how many points do I still need? I need just one more point that was not used yet. And what point is that? It's x-intercept, which is 2 and 0. Not so. We're going to substitute 2 and 0. Again, that's an x and a y. So 0 is equal to 2 cubed plus q times 2 minus 8. That gives you negative 2 cubed is equal to, cancel, 0. So q is also 0. Q is 0, p is 0, and r is negative. Right, you guys understand? Any confusion? Any questions? So you got x cubed minus, that's what we have so far. Okay. That basically confirms my statement earlier on, where the turning point and the point of inflection seem to be at the same point. Right? Well, no turning point and the point of inflection in this case. If you go to the next question, the next question tells you to sketch the graph of graphs of f of x, f prime x, f double prime x on the same system of axes, showing all the intercepts of the axis as well as the coordinates of the stationary point of points and the point of points of intersection. So from here, people, we know we have most of the information already. Okay, so that's y, this is x. I'm going to draw f of x first. We know it's going to cut your y-intercept at negative 8. So negative 8 is approximately there. Then it's going to cut your x-axis at 2. Okay, so the graph is first going to go up and down. The point of inflection is at 0 and negative 8, which is this point here. You see that, people? So the graph is going to come from, remember the graph is going to go up then down, so it's going to start from the minimum and proceed to the maximum there. So I'll draw it like this. So there is that graph. This is the f of x. Then your first derivative, one function am I doing for the first derivative, f of x, f prime x is going to give you 3x cubed squared. So what's your x-intercept here? 0, y-intercept 0, the graph is smiling. So that is why that graph is multiplied. So we come a bit down and we go through that point. Okay, this is f dash of x. Okay, so your second derivative, okay, it's important for us to at least have a point on this graph. So let's see where 2 and 0 will be there on the f of x. But if I substitute 2 into this graph, we'll have 2 squared is 4 times 3 is 12. So this point here is 2 and 12. Do I need that point? I don't really need it. Okay, I'm just putting it for additional information there. And for your second derivative, which is going to give you 6x. So I draw this y is equal to 6x draw. Y-intercept 0, x-intercept is 0. So we need another point to draw this graph. So let's substitute 2 in. So if x is 2, y is 12, which is also that point. With the ruler I draw this line, and that is my f double dash of x graph. Okay? Do you guys understand? Again, that relationship comes up that if A is positive, then what happens? The graph first comes up and down. Secondly, the first derivative will be quadratic, smiling quadratic, and the second derivative will be an increase in the new function. Okay? Something that needed to be mentioned at this point. Okay, any confusion there, people? Let's look at the last one. Example 5. Example 5 on page? Same page. 173. So it says consider the function g of x equal to x squared plus ax squared plus bx plus c, which passes through the origin. It has a tangent given by the equation y is equal to 24x minus 54 at x equal to 3. Determine the value of a, b, and c, showing all necessary calculations. People, what I do is I just draw the information given to me. Okay, so what I do is I draw a tangent and a cubic function. It's not necessary that it will be like this. It might be something in that format as well. But how do I know it's going up first then down? It's because A is positive. Okay, just to give me an idea of what we have. Okay, a visual idea of what I have. So consider the function, this here, which passes through the origin. Okay, so it's going through the origin, what do we know? That it can be there, it can be anywhere on this curve. Not so, but let's say the origin is here. Okay, which passes through the origin. I'm not going to put it on the turning point, although it could be on the turning point. I'm not going to put it on the turning point because I didn't mention it there. You guys understand? So it's going through the origin, which is 0 and 0. And as a tangent to the equation wise, a tangent at x equal to 3. Let's say x is 3. Again, it could be anywhere on this side of 0, not so. A tangent here. And the equation of this tangent is y is equal to 24x minus 54 at 3 and some y value. Did you see that, people? So that's the information that we have. Alright, so to calculate the values of A, B, and C, of course I need three parts to this information. Okay, so when we start, we'll start with 0 and 0, that's the easiest part. Because the graph is going for 0 and 0, if I put 0 in the x, I get 0 on the y. Okay, so what I'm going to do is, I'm going to substitute the origin, which is 0 and 0. That's the x and the y. So g of x is the y, of course. So I say 0 is equal to 0 cubed plus a times 0 squared plus b times 0 plus c. So what is c? 0. So c is 4. Okay. Then, this is a tangent. People, how do you calculate a tangent to a cubic function? First derivative, and then set the x value in. When we work out the first derivative, if you set the x value into that first derivative, what do I get? The gradient at that point. Not so. So what I'm going to do is I'm going to work out my first derivative. I'm going to use this here. So I go g dash of x equals 3x squared plus 2ax plus b. People, this is your first derivative. So what is this? Your general gradient anywhere along the curve of g of x. Now, so that is your general gradient anywhere along the curve of g of x. You're right. But we know that it's so. If this was a normal equation without variables here, a normal expression without variables, if I substitute 3 in, then I will get a gradient at 3. Not so. But what do we notice here? If we substitute 3 in, my gradient must be 24. So the gradient is given. So in other words, f prime of 3, the gradient of 3 is already 24. That is known to us. Make a note of this. Okay, learners always mess up this under pressure. Okay, they don't make this link here. This again, if you work out the first derivative, is the general gradient anywhere around this curve. If I substitute the x value in at that point, I will get the gradient at that point. Okay? So, because we have the equation of the tangent at 3, what is the gradient of this tangent? 24. Which means to say, if this was a normal g of x graph without the variables, and I worked out the derivative, and I substituted 3 in, I would have gotten 24 out. So the gradient at 3 is 24. And it's not if it's g of x. So with that information, I'm going to say, okay, g prime of 3 is 24. So it's going to be 3 times 3 squared plus 2a times 3 plus b is equal to 24. I drop that. There's no way to 24, no? So that is 9 is 27. So b is equal to, that is going to give you negative 6a. 24 minus 27 is negative 2. So what do I notice now? I have 2 unknowns. Did you see that? So this will definitely go into simultaneous equation. So this is equation 1. Okay. So now I need another bit of information. So we use that. We depleted that. We have used 3 and the gradient. But if I can calculate this y value here, then I can substitute 300 y value also into this equation here. Not so, to get the second equation. Okay? So again, If I got this corresponding y value, if I substitute that x and y into this, the equation now stands at g of x is equal to x cubed plus ax squared plus bx. If I substitute this x and y value into this equation, I will then get a and b, another equation dealing with a and b. You guys understand? So let's slow this down a bit. Now, how are we going to get this other y value? Are we going to obtain that y value? Substitute 3s into the equation of? Can I go with g of x? No. Why not? The g of x have too many unknowns there. But what is this point to us? This was the point of dissection. So what does that mean? That means to say that the cubic function is equal to the linear function with a tangent. Not so? Because that's the point of contact. So what I do is I substitute 3 into the tangent. By substituting 3 into the tangent, I get the corresponding y value. You guys understand? Let's go with the substitute. X is equal to 3 into the tangent. It's the equation. So we have y is equal to 24 times 3 minus 54. What's 24 times 3? 72. No? 72 minus 54? Something with that 18, I think. It will be nice if you guys take out the calculator. I haven't seen the light of day all weekend. 24 times 3 minus 54. So what does this tell us, people? That this point is 3 and 18. So what do I do now? I'm going to substitute. 3 and 18 into 0. Substitute 3 and 18 into 0. That's an x and a y. So I have, that's a y, no? So what do I say? 18 is equal to 3 cubed plus a times 3 squared plus b times 3. 18 cubed, 3 cubed is what? 27. What's 18 minus 27? Negative 9 equals 9a plus 3b. Okay. So I'm going to divide by 3 just to simplify the sum. If negative 3 is equal to 3a plus b. And this is the equation. So what do I do now? Well, I can do the simultaneous equation, not so. So you're going to substitute equation 1 into equation 2. So what's going to read now? If I see a b, I replace it with negative 6a minus 3. So it's negative 3 into 3a minus 6a minus 3. So it's going to give us negative 3a equals 0. So a is 0. And then b, of course, the equation 1, so it will be negative 6 times 0 minus 3, which is negative 3. So there's your a, your b, and your c. Okay, so I'm like this worth 5 or 6 minutes. Okay. It's only if you want it. And most of us don't want it. Okay? Will you guys understand? So let's pull this in here quickly. So my equation now reads g of x equal x cubed. What is the value for b? A was 0 or b was 0? A was 0, no? So it's going to be minus 3x plus 0. So your equation is x cubed minus 3. Okay, you all okay with that? So I'm going to take off what we've calculated thus far. So we can have space. Okay. Let's look at number 2. Number 2 says, if A is equal to 0, B is equal to minus 3, and C is equal to 0. Now people, in the exam, you'll also get this case here, where they tell you, if A is equal to that, and B is equal to that, and so on. Even if you're convinced that the examiner made a mistake, no? Which is all the time. No? So you guys know better than the examiner. You must still use these values. Okay, because even if you use your correct answers, you won't get marked. You won't get the positive mark here, or your CA marking, consistent accuracy, because you are using something other than what is given. You understand? So it's either one of two things. This either confirms your information there, that from the previous question, or if you didn't get that, you must use this. Okay? Otherwise, you're not going to be awarded any marks there. Okay? The question says, in 2.1, determine the equation of the tangent to G, which is parallel to the tangent at x is equal to 3. Okay. Again, determine the equation of the tangent to G, which is parallel. People, if lines are parallel, what do we know? Radians are equal. It's like somebody did here homework, no? So now, this gradient here, this tangent, would be approximately here as well. Will it go through the 0 and 0? I don't know. It could go, but it doesn't mean to say it will. Okay? It is just by chance that it looks like it's going through the 0 and 0. Remember, this point here could have been anywhere along that curve, as long as it's before the 3. Not so. It's going to be there. Again, if lines are parallel, gradients are equal. So what is the gradient? What is the gradient of the current, the first tangent? So the gradient is equal to 24. Not so. But let's take one step back. How do we normally get this? You work out first derivative, not so. So first derivative is our general gradient. You want to agree with that? First derivative is our general gradient. If I put my x value in, I get my gradient out. Not so. But what will happen if I set my general gradient equal to the gradient? Then I will get the x value at which the gradient occurs at. Where that gradient occurs at. You guys understand? Alright? So what is the general gradient? 24. Let's say 24 is equal to 3x squared minus 3. They get over the equal sign becomes 24 plus 3 is 27. Divided by 3. X squared is equal to 9. Square root. Plus minus. Why am I getting two solutions? Because there's two places on this graph where you have a gradient of 24. Can you see that? The one being at 3, which is the one where it is known, and the other one is going to be at negative 3. So which means to say I would assume now 0 and 0 to be approximately here at the point of inflection by the tip. So can you see that, people? So let's look at this here. By our findings at this point, the point of inflection is about there. Why? Because the point of inflection also happens between your two turning points. Okay. And as you can see, the gradients are the same, so it's also going to happen between the midway between those two. Okay, so have we answered the question? Determine the equation of the tangent to G, which is parallel. Have we answered the question? No. So we know that this point here is going to be minus 3 and some y value. How do we get that y value? You substitute it, yes, where? Into which equation? Of g of x. We'll substitute that into the equation of g of x. Okay, so we now say g of minus 3 is equal to negative 3 cubed minus 3 times negative 3, which is negative 287 plus 9, which is negative 18. Okay. Negative 18. So this point is 3 and negative 18. So what do I do now? What is the equation of this line as it stands here? Y is equal to 24x plus c. Not so, why? Because the gradients are the same. Alright? So what do we do? We now say we're going to substitute negative 3 and negative 18 into y is equal to 24x plus 6 plus c. Sorry. Alright? So there's an x and a y. We've got negative 18 is equal to 24 times negative 3 plus c. So c works out to be negative 18 plus 24 times 3. To give you an answer, 54. Alright, so that's my equation. Therefore, the other one would be y is equal to 24x. The other equation is y is equal to 24x plus 54. To check if that's correct. Yeah, 24x plus 54. Any confusion there, people? So we put this here so that I can again erase. We want to keep the diagram in focus. Okay. Let's look at the next question. Determine and classify the stationary points, showing all necessary calculations. Okay. So how do I work out my turning point before? First derivative, set it equal to 0. Alright, so we do g prime of x is equal to 3x squared minus 3. Set it equal to 0, drop that. So 3x squared is equal to 3, x squared is equal to 1, so x is equal to plus minus 1. How do I get the corresponding y value? Substitute this back into g of x. Not so. So g of 1 is going to be 1 cubed minus 3 times 1, which is negative 2. So the 1 point is going to be 1 and negative 2. To this point here. Not so. 1 and negative 2. And then g of negative 1. So there will be negative 1 cubed minus 3 times negative 1. Negative 1 plus 3, which is 2. That is negative 1 and of course this is your local minimum. This is your local max. Okay, if you want to do it by calculation, of course, you're going to substitute 1 into your second derivative. Okay, just work on your second derivative here. So g double dash of x is going to give you 6x. Okay, we'll substitute 1 in here. What's 1 times 6? 6. Okay, and that is positive. And if 6 is positive, it will be local min. If you substitute negative 1 in here, you will get negative 6. And if that is negative, it will be a local min. Okay. Any other confusion there? Beautiful, huh? Sounds. I almost feel like this is the reason why we're doing algebra all the time. For calculus. Determine the point or the points of inflection of G. So we just work with one point of inflection, not so. I don't know what they're trying to fool here. Okay. We draw the x to the power 4 graphs and 5 and so on, then you get more points of inflection accordingly. Okay. So determine the point or the points of inflection. So what do I do for point of inflection? I work out my second derivative. Okay. So I got my first, I'm stop erasing the derivative. And then your second derivative, of course, is going to give you 6x. So what do? I say this is equal to 0. So I drop this. So x is equal to 0. Alright. Determine the point. Okay, so what do we do with this? We sub that back into the g of x graph, not so. So g of 0 is equal to 0 cubed minus 3 times 0, which is 0. Which confirms that the point of inflection is at 0, 0. Remember I mentioned that earlier on. Okay. But here is by calculation as well. Therefore the point inflection or the origin is 0, 0. Okay. And then of course the last question. Sketch G now showing the intersection of the axis and the coordinates of the stationary point or point. And now I don't need not to erase this. I don't. But anyway. So if we're going to draw this now, people. So I'm going to pull this here. I have everything already. Not so. Well, I'm going to just pull this down. You can have a clear picture of what's happening here. This is now 2.4. Alright, let's go. The favorite part, no? So, of course, we're going to go through 0 and 0, which is the origin. We don't have the x and y intercepts. Okay, so the equation was g of x is equal to x cubed minus 3x. Is that correct? X cubed minus 3x. So how do I work out x-intercept? Y equals to 0. So 0 is equal to x cubed minus 3x. Take out x as a common factor and left with x squared minus 3. So x is equal to 0 or x squared is equal to 3. Take square root, goes plus minus. Not so. So you got 0 and x is minus root 3 and root. About the same. You all agree with that? Then we have tan. So make this a bit bigger. Okay. Then of course we have turning points. The turning points at negative 1 and 1. So what I do is I draw normally a dotted line here. give you a guide. So x is equal to minus 1. But it's more. Half of, remember the root of 3 is 1 comma something. Eh? Let's figure root 3 is 1 comma 7. Half of 1.7 is 1.89. So it's just under half. Again, it doesn't have to be exact, it's just approximation. Okay, so again, that is, let's just leave about this and all. Again, I don't need this information now. We'll take it, it's on the diagram. Because of space here, so I say x is equal to 1. But on this graph, it's turning at negative 1 and 2. Negative 1 and 2, and it's going to turn here about in the same length here. This 1 and 2. And 1 and negative 2. Okay. So remember the graph goes up and down. So from the turning point I draw, going through there. Okay. And there's my cubic function that I asked you to draw. Is there any confusion here, people? Just coming back to I'm going to do it on both. I didn't ask you to on both accounts, but I'll answer it in both cases. If the one question they didn't ask you with regards to concavity, where's the graph concave up, concave down, and things like that. Not so. So where's this graph concave up? As you can see here, this will be concave down. The graph is concave. This was not asked, okay? Concave down. When is it concave down? For x is less than 0. Not so. Where's the graph concave up? Concave up for x is more than 0. At 0 is neither concave up nor down, it's neutral. Okay? So you won't put equal signs there as well. And then the previous one in question 4. And this was the graph in question. So here's the point of inflection. So this part is considered as concave down. Not so. And this concave down for x is less than 0. And of course that is concave up. Concave up for x is over. Okay. Any questions, people? This brings us to the end of the example for exercise 3.